Hello everyone. Today we'll perform the experiment positive and negative clampers with and without reference. We'll perform it in LT-SPICE. Uh, Let us see some theoretical part. A clamper circuit is basically seen as a level shifter. Uh, if you look at the figure, if we have an input waveform like this is the level, DC level. This level will be shifted either above or below, depending on what kind of uh, clamper circuit we are preferring. Here in this example, positive clamper circuit, it means we can see the output waveform. It is the level is shifted above. Okay, the zero level means the output waveform is above this level. And for negative clamper, we can see here for negative clamper, if this is the input, we can see the waveform is shifted below. It means we will shift the waveform either above or below. Positive clamper means we are shifting it above this zero level. Negative clamper means we are shifting this waveform below the zero level. Basically, there are two types. One is positive clamper and negative clamper. And again, applying biasing means depending on what kind of DC bias we apply, again, we can classify it into two, like positive clamper with positive bias and with negative bias. Again, the negative clamper with positive bias and with negative bias. In our experiment, we are just performing positive clamper and positive clamper with positive bias, negative clamper with negative bias. If you see the circuit operation, this circuit, we have a capacitor, a diode, and a resistance. Normally, when the positive half cycle comes, this is positive and this is negative. This terminal becomes positive and this terminal becomes negative. In which case, directly output is applied to a resistance. This will not consider for the first half cycle. When the negative half cycle comes across the terminals, then this terminal becomes negative and this terminal becomes positive. Negative connected to negative of diode, positive connected to positive of diode. Diode is said to be forward biased. When it is forward biased, the capacitor charges. The capacitor charges to the peak voltage, peak input voltage. This is the input waveform. We can see the peak input voltage is Vm. So the capacitor is charged until Vm. When the next half cycle comes, it means when the next half cycle is positive half cycle comes, again the terminal here becomes positive and this one becomes negative. So diode is reverse biased. When the diode is reverse biased, then this is open circuited and output is appearing across the load resistance. In this case, output V0 is equals to the voltage what we applied at the input plus the discharged voltage from the capacitor. In the previous cycle, the capacitor was charged to plus Vm. So that voltage will be discharged when this is open circuited. So we see that V0 is equals to the applied input voltage plus the discharged capacitor voltage. Therefore, we see that output waveforms is clamped, means has shifted above this zero level. Next, positive clamper with positive bias. Simply the circuit, in this circuit, we will add one DC supply. So depending on what value we give, that value will be the reference value. The waveform, output waveform is shifted above zero, but this reference value will be equal to the DC bias voltage. For example, if I say that if I give 5 volt here, then this reference value will be equal to 5. This is positive clamper circuit. Negative clamper, when input voltage is given here, you can see diode is connected in opposite direction. When the positive half cycle comes, this terminal becomes positive and this terminal becomes negative. Positive connected to positive, negative connected to negative. The diode is forward biased and it conducts and it is short circuited. Therefore, the capacitor charges to its input's peak voltage, which is Vm. And output, we will not get any output here. The next cycle, when the negative half cycle comes, then this terminal becomes negative and this terminal is positive. Therefore, the diode is said to be reverse biased. In this case, when this is reverse biased, this is open circuited. Therefore, output is appeared across the output or the load resistance, where V naught will now be equal to the discharging voltage, the discharged voltage of capacitor plus the input voltage, which is equal to V naught equals to Vi plus Vm. Therefore, we see that output waveform is simply below the zero level, and which is equals to 2 Vm minus 2 Vm. And negative clamper with negative bias means we are applying a negative bias. We are applying a negative to the diode, negative terminal to the diode, and the operation remains same. Only thing is this reference level will be equal to whatever DC value we give here. If it is 5 volt, means the reference level will be equal to 5. Let us perform the experiment in LT spice. For this, initially I need a voltage source, a capacitance, resistance, a diode, will connect all the components. We specify the values. We'll select sine wave with amplitude of say 10 volts and frequency of 55 hertz, and capacitance value say 1 microfarad. Diode, let me select 1N914. Resistance, let me select 100 kilo ohm. And stop time at 0.05. This is a positive clamper. If I run this, okay, you have to give a ground connection. Okay, this is the input and this is the output. You can clearly see that the blue line indicates the output waveform, which is above the zero level. This is the zero level. Okay, this is the zero level. It is above the zero, which has been clamped. And this green level is the input wave. This is positive clamper. If for the same circuit, if I add a voltage, a DC voltage, that is battery, and say if I give the value as 5 volts, then this is positive clamper with positive bias, positive reference voltage. In this case, you can see that this is input waveform with the DC level of 0, and the output waveform is at the level at 5 volt. Okay, the reference level at 5 volt, because the battery or the DC supply what we have considered is of 5 volt. Similarly, we will perform negative clamper. For negative clamper, simply what we'll do, we'll just reverse this symbol, diode direction. This is a negative clamper. You can see the blue line is the negative clamper output waveform, which is simply below this zero level. If we want to perform the next circuit, which is negative clamper with negative bias, I'll reverse this supply, DC supply. Say if I give it as 5 volts, You can see at negative 5 volts, uh, the zero level, sorry, the output waveforms level is, reference level is below this 5 because the DC supply what we have taken is 5 volt. This is about the experiment. Thank you.